Everybody, this is going to be the video for the Unit 2/3 FRQ examples. I've pulled 6 different free response problems from previous years. These problems will cover the things that are in your study guide just for this unit. So this first question was from 2018. It's just going to be part A. This question gives us this table right here, and it's talking about the height of a tree throughout time t. So you see in this table you have the top row is time, the bottom row is the height of the tree throughout those years. The first part of this question asked, use the data in the table to estimate h prime of 6. Okay, this is a very common type of question where they ask you to estimate h prime. What this is asking you to do is use your average rate of change. When it says the word estimate, that's asking for the average rate of change over some time. The way you know when to which coordinates to use, since average rate of change is rise over run, you need 2 coordinates. And you look at that point right there, 6, and you want to look at which coordinates in your table are closest to 6 or around 6. So here 6 years would fall in between 5 and 7 years. And so we want to use these 2 coordinates here for time equals 5 and time equals 7. So the way we would write our workout for this is we would write that h prime of 6 is approximately equal to, since this is an estimation, I'm going to use the squiggly equal sign here. And average rate of change, if you look on your study guide, the first box, rise over run, y2 minus y1 over x2 minus x1, and we're looking around the value t equals 6. So here we'll have, it's approximately equal to h of 7 minus h of 5 over 7 minus 5, which is the same thing as we just plug in our values, 11 minus 6 over 2, which is the same thing as 5 over 2. And now it's asking us to interpret the meaning using correct units. So we're not done with the problem just because we found the approximate value of h prime of 6. We have to interpret this meaning in terms of the problem. So what this is saying is that if this is a rate or an approximation for the rate and our units are meters, the rate at which the meters are changing would be meters per year. So we can say that h prime of 6 is the rate at which the height is changing in meters per year. Okay, so we've included our units and we've included the interpretation that it is the rate at which the height is changing. So nowhere in this problem did it say the word rate of change in there. It just said use the data to estimate h prime of 6. You have to know that it's asking you to find a rate of change. And so once you write those words, rate at which the whatever is changing, in this case it's the height, is changing, and you have to use the correct units, meters per year. And then you have all the elements to get full credit for this part. Alright, the next question is number 5 from the same test in 2018. This says you have this function f of x equals e to the x times cosine of x. Parts A and B both fall under units 2 and 3. The first part is average rate of change, AROC, and the second part is asking for the slope of the line tangent to the graph. Okay, so let's just first start with part A. AROC is y2 minus y1 over x2 minus x1. So all we need to do, so I'll write part A is going to be, so our y2, or x2 and x1 are right there, 0 and pi. So we're going to do e to the pi times cosine of pi minus e to the 0 cosine of 0, y2 minus y1 over x2 minus x1. Rise over run. So this is a non-calculator problem. All the problems on the free response test this year can be done without a calculator. So remember that your expression can be left in terms of e and pi, and as long as there's no variables in there, you can leave it in terms of that. And so if you were to simplify this one more step just to make it a little bit cleaner, you could just leave it as e to the pi. Cosine of pi is -1. So put a negative in front of there. So we got negative e to the pi minus e to the 0 is 1, and cosine of 0 is also 1. So negative e to the pi divided by 1, all divided by pi. And there's the average rate of change. Nice and clean. You don't need to simplify it further. You could leave it in terms of e and pi. Don't waste your time typing it into the calculator. All right, part B here asks us to find the slope of the tangent line. All right, tangent, if you look on your study guide, I drew that the tangent line touches the graph at one point. That's IROC, instantaneous rate of change. So we want to find f prime of 3 pi over 2 is asking us to plug in 3 pi over 2, and slope of the line tangent would be f prime. So we need to find the derivative here. So we use the product rule, derivative of the first times the second, plus derivative of the second times the first. So derivative of the second is going to be negative sign. So I'm going to put a minus here, e to the x sine of x, and we just need to plug in our 3 pi over 2. So f prime of x, f prime of 3 pi over 2. So we got e to the 3 pi over 2 times cosine 3 pi over 2 minus e to the 3 pi over 2 times sine of 3 pi over 2. Okay, and so notice how they both have an e to the 3 pi over 2 at the beginning, but we need to figure out what's cosine of 3 pi over 2 and sine of 3 pi over 2. So if we go around our unit circle to 3 pi over 2, cosine of 3 pi over 2 is 0, so this entire term zeroes out, and sine of 3 pi over 2 is -1. And there's already a negative here, so negative times negative is a positive. So we're just left with the positive e to the 3 pi over 2, and that's the slope of the tangent line there. Let me just confirm the answer just to make sure that I didn't miss anything here. Okay, great. E to the 3 pi over 2, perfect. Okay, let's keep going. Next page. Okay, this is question 4 from 2015. What we got here is a differential equation, dy over dx equals 2x minus y. And this is part B of this problem. It's asking find d squared y over dx squared. Okay, so we have dy dx. We're going to need to use implicit differentiation. So just one little tip here, differential equations are often associated with implicit differentiation because differential equations usually have x and y's mixed up together. So these two usually go hand in hand with each other. You will see them often in the same problem. So here we have to find the second derivative, or d squared y dx squared. And there's a little bit of notation there. This is the same thing as y double prime or f double prime of x, that kind of thing. And it says determine the concavity of all solution curves for the differential equation. So we're looking for concavity here. We need to see what is the sign of the second derivative, and that's going to tell us something about the concavity, about the solution curve. The solution curve is, you could translate that back to y, or the original function. And so d squared y over dx squared is the second derivative. Okay, so we have to take this, the derivative of this guy right here, because we can think of dy dx as the first derivative, and I need to take y double prime here. Okay. So if I take the second derivative, I'm going to treat each term individually. So the derivative of 2x is just a 2, and the derivative of negative y is negative dy over dx. We're using implicit differentiation here. So I got 2 minus dy dx. Now what you need to do here is recognize that if I want to evaluate this guy, I can replace dy dx with whatever it's equal to. So we got 2x minus y. Just go ahead and replace that in there. So I can just make this equal to 2 minus parentheses 2x minus y, which is also equal to, if I distribute that, negative 2 minus 2x plus y. Okay, so quadrant 2, if I have my x and y axis, here's quadrant 2. If I look at the x values are negative, x is negative, and the y's are positive here. So if I take a look here, let me just pick any point here. I just need a negative x value and a positive y value. So let me just pick negative 1, comma 1, just as a point to test in here. Now if I plug in a negative x value, it makes this guy positive, and if I plug this guy in a positive y value here, that's going to make this positive as well. So all these terms are positive, which means that using any coordinate from the second quadrant, whatever I plug into here is always going to be a positive value. So I'm going to put that this is always greater than 0. And remember, this is the second derivative. If I have the second derivative always being positive in the second quadrant, then that means that I can say the solution curve will be, since we have a second derivative positive, this will be concave up in the second quadrant. And we have to put a because. Justification, we have to give a reason, because d squared y dx squared is greater than 0 in the second quadrant. Okay, I have to explain all of that in a sentence, otherwise I won't get full credit for it. Okay, let's move on to the next problem. This is number 6. Number 6B and 6C from the 2017 AB test. The problem gives us a table with G and G prime values for those two columns. It also gives us the graph of H. We have a lot of different things going on here, and the problem also gives us an equation for f of x. Part B asks us to find k prime of pi, and it gives us that k of x is h of f of x, and I want to take the derivative of that. So I'll do the work for part B over here off to the side. If I want to find k prime of x, and I know that k is equal to h of f of x, this is going to be a chain rule. This is indicating to you I have a composition of functions, a function within a function. So I first need to derive the outside function. So I have h prime of f of x, but then since I took the derivative of something with a function within it, I need to now multiply by the derivative of the inside function. This is the chain rule. Okay, so we have h prime of f of x times f prime of x. And now I just need to plug in a pi to that. So k prime of pi is equal to h prime of f of pi times f prime of pi. Now here's where people get confused often, is this guy right here, f of pi. This value is going to be the input for the h prime part as well. So if I take a look k prime of pi is going to be h prime of something. Now f of pi, here's my function, cosine of 2 pi plus e to the sine of pi. So if I plug in a pi into f right here, this is cosine of 2 pi. Well, if I go all the way around the circle, unit circle back to 2 pi, cosine of that is going to be a 1. So this is going to be a 1 plus sine of pi. Sine of pi is going to be 0, so e to the 0 is also a 1. So I have 1 plus 1 is 2. So the input now for this guy is h prime of 2. And then I now need to find f prime of pi. Take the derivative of these guys. F prime of pi. Now if I take a look, you can work this out on the side on your own. But f prime of pi, if you take the derivative of this and plug in a pi, you'll end up getting a negative 1. So multiplied by a negative 1. To find h prime of 2, I need to go to my graph. Here's 2, and h prime is the slope at that point. And if you look at your graph here, it's going down 1 over 3. This is a slope of negative 1/3. So now I have k prime of pi equals negative 1/3 times negative 1, which is equal to positive 1/3. And there you go. There's your derivative of k evaluated at pi. All right, and we have part C. Kind of a similar idea here, except we would need to apply the product rule. We're trying to find m prime. I need to do the derivative of the first times the second plus derivative of the second times the first. So over here I'll do m prime of x is equal to, now the derivative of the first is going to be g prime of negative 2x. But since there's a negative 2x inside of here, I need to multiply this times the derivative of negative 2x, which is a negative 2. So I'll put a negative 2 out in front there. So it's derivative of the first times the second plus derivative of the second times the first. Okay, if I plug in a 2 here, this is going to be negative 2 times g prime of negative 4 times h of 2 plus h prime of 2 times g of negative 2 times 2 is negative 4. And now I just need to go and find these values. So we've got a negative 2 times g prime of negative 4. G prime of negative 4 is a negative 1. So I got negative 2 times negative 1 multiplied by h of 2. Well, here's h. H of 2, if I look right there, that value should be negative 2/3. And the reason I know that is because of this slope. It goes through, the graph of h goes through 0 and negative 1, and so that slope is negative 1/3. Each time you increase a unit, you're going down 1/3. So this is negative 2/3. Now I have plus h prime of 2. H prime of 2 is negative 1/3, the slope there, which we talked about earlier. So negative 1/3 goes right there. And then I have g of negative 4. G of negative 4 is 5. Okay, make sure I put the equal sign up here so I connect all my work. Now I just compute all of this together. And this should be equal to negative 3 when you simplify it all down. Technically, you could just leave it like this if you'd like. It's a numerical expression. No functions, no variables, it's all values. You can leave it like that if you don't have time to simplify it, or if you don't have a calculator. This is completely acceptable. Because if you made a mistake here and finished up here, and it got the incorrect value, you wouldn't get points for this step. So you could just leave it right here to be safe. Okay. Alright, this is question 1 from 2014. It's saying grass clippings are placed in a bin where they decompose. For time 0 to 30, the amount of grass clippings remaining in the bin as the grass clippings decompose is given by this function right here. And this function is measured in pounds, and t time is measured in days. So part A and part B here are talking about average rate of change and instantaneous rate of change. So part A says find the average rate of change on the interval 0 to 30. So average rate of change indicates to us that we need to do our slope formula y2 minus y1 over x2 minus x1. Okay, so this was question 1 from a past year, so this was a calculator active problem. So we can use our calculator, which I'll show you just real quick. I won't show you for part A because part A is just simply typing in this guy right here with 30 and 0 plugged in. So it would basically just look like what you're typing in would look something like this. A of 30 minus A of 0 over 30 minus 0. And so A of 30 is just this entire thing with a 30 for t as the exponent, and then minus the same thing again with 0 as the exponent. So you can type that into your calculator, figure that out. You don't really need to show that if this was a calculator problem. But the simplified value that you get here is going to be negative 0.197 pounds per day. Okay, and this part is essential, pounds per day, in order to get you full credit. Anytime the part of the problem asks you to do something specific, that means they're giving you points for doing that thing correctly. So just the first part with the equation getting negative 0.197, that would have gotten you 1 point. But just writing pounds per day would have gotten you the second point to this part. Having that part would have allowed you to get full credit on this question. So make sure that when it asks you to put units, you write down the correct units. This one was pounds per day. It tells you pounds and days are part of the problem. So there's part A. Now part B is where the calculator comes in a little bit in handy. It says find the value of a prime of 15. And we've got this complicated exponential function here, but since it is a calculator problem, you can figure out a prime of 15 without doing any handwritten work. So a prime of 15, if you go to your calculator and you push math 9 on the regular home screen, sorry, not math 9, we're going to go to math, and then if you scroll down, math 8. 9 would be the integral, 8 is the derivative at a point. So we're going to do math 8. And notice how it gives us this little open template for a function. So this d over d blank, we're going to put an x in there. d dx, that is meaning take the derivative, and then inside the parentheses, that's what you're taking the derivative of. So inside the parentheses, we're going to put 6.687 parentheses 0.931. Close those parentheses, and we're going to take this to the power of x. There we go, x. And this won't give us the general derivative, it gives us the value of the slope at a coordinate. So the calculator won't give you the general derivative, it has to be with the value plugged into it. So we're going to plug in a 15 here, and we should get our answer right here. And so the safest thing on any free response problem is to always leave more than 3 decimal places. You can round, but don't go less than 3 decimal places. So the answer that the rubric gives here is 0.164, because right here you have 0.163590, this long decimal. So you can round it, but if you round it differently than 0.164, you will get the incorrect answer. So to be safe, what I always give advice is just write down the entire decimal and you're safe. 1.6359, and you could write more than that, but as long as you've hit that 3, I usually put 5 or 6 just to be safe. Okay, but there's your answer. And we also need to include the correct units, interpret the meaning of the value in context of this problem. So what this means is that at time equals 15 days, okay, this is a rate of change at a specific time in the interval. So at t equals 15 days, the rate of change of grass clippings is negative 0.16359 pounds per day, lbs per day. So let's just make sure we covered all the grounds here. We have at a particular point that needs to be there, the rate of change of grass clippings is the value of the rate as well as the units, pounds per day. So you need those three things right there. At a moment, the rate, and the units. Okay, if you don't put those three things, you won't get full credit for the problem. Okay, so there's part B. And then here's number 5 from the 2014 test. This is part C. This includes a couple of different concepts. It includes taking a derivative of natural log. It also includes a chain rule, and it includes using this table up here to try to determine what's the value of h prime of 3. And it says show the computations. If it tells you to show something, you need to show that work in order to get full credit. So this is part C. If I want to find h prime of 3, I have to first start by taking h prime of x. Now the derivative of natural log to the something is, first of all, 1 over something, 1 over whatever's inside of the natural log, so 1 over f of x. But since the something inside is something other than just a simple x, we need to multiply by f prime of x. This is the chain rule right here, times f prime of x. And then you could just write this as f prime of x over f of x. Either way works. I'm going to continue this work. H prime of 3 now, if I plug in a 3, it's going to be 1 over f of 3 times f prime of 3. So now I need to go into the table and pull these values. So f of 3 I need to locate somewhere up in this table. And I know it shows these intervals in here. Those were used for other parts of this problem. So if you want to go work the rest of this problem, you'll have to use some of these other columns where it says positive, negative, increase, decrease, all that kind of stuff. Right here, we're just interested in the value of f of 3. So here's the f row, and here's 3. So f of 3 is 7. So my first part here is 1 over 7. And now I need to find f prime of 3. F prime, this row right here, is f prime of 3 is 1/2. So times 1/2, multiply across, we get 1 over 14. Boom, we're done. Okay, so all these problems we're covering things to do with just the derivative, applying or evaluating the derivative, as well as talking about rate of change, average rate of change, instantaneous rate of change, things all related to that. That's all topic 2 and topic 3 problems. As always, if you have questions, please email me. Let me know if you would like me to work more examples or things like that, or I can point you in the right direction.